Alright, 8.2 notes, or Module 8A notes, dividing polynomials. In this unit, there are two objectives. One is to divide polynomials using polynomial long division and synthetic division, and two is to use division to factor and solve polynomials. So these are the two things that you'll need to be able to do for this module. Polynomial long division is the process where you divide a polynomial f of x by a divisor d of x, and you get a quotient polynomial q of x and a remainder polynomial r of x. So basically what happens is when we divide a polynomial by another polynomial, we get a polynomial plus the remainder polynomial over the divisor polynomial. So the divisor polynomial becomes the denominator of our remainder fraction. Now, polynomial long division basically works the same way as regular long division, but instead of using numbers, you're using polynomials. We also want to make sure that we use placeholders for any missing terms. So that's going to be important. We had to use placeholders when we evaluated polynomials. We had to use placeholders when we added, subtracted, and multiplied polynomials. And we need to use them when we do division as well. And the other tip that I'll give you here is that when you are looking for what you can divide by, focus on the first term of your divisor. So that's the highest degree term of your divisor. Remember, your divisor is what you are dividing by. So we'll look at this example here to get an idea of what this looks like. The first thing I'm going to do is write out my first polynomial, which is called the dividend, and I'm going to put in placeholders for missing terms. So I have 3x to the fourth minus 5x to the third. I don't have an x squared term, so I will say plus 0x squared as my placeholder. Then I have plus 4x minus 6. And I'm going to put this under that division bracket that I use for long division, and I'll put my divisor on the outside. So x squared minus 3x plus 5. Now I'm going to focus on the first term here of my dividend and the first term of my divisor. Remember, when I'm asking these questions, I focus on the first term of the divisor. How many times does x squared go into 3x to the fourth? Or what could I multiply x squared by to get this term? The answer there is 3x squared. So now I take 3x squared times x squared and get 3x to the fourth. 3x squared times negative 3x, so I multiply this times every term here, and then I will line them up underneath each column. So 3x squared times negative 3x gives me negative 9x cubed. 3x squared times 5x gives me 15x squared. Now I will subtract, just like I would in regular long division. These first two should cancel. Then negative 5 minus negative 9 is plus a positive, so I get 4x cubed. 0 minus 15 gives me negative 15x squared. And then I bring down my next term, which was a 4x, and it's positive, so it's adding. Now I'm going to come back to my first term of my divisor. How many times does x squared go into 4x cubed? And the answer there is 4x. So I say plus 4x. And then I repeat the process. 4x times x squared is 4x cubed. 4x times negative 3x is negative 12x squared. And 4x times 5 is 20x. Then I subtract again. These two should cancel. Negative 15 minus a negative 12 is plus a positive 12. So that's going to leave me with negative 3x squared. And 4 minus 20 is negative 16x. And then I'm going to bring this over here, or bring this 6 down. So I have minus 6. Now I need to find out how many times does x squared go into negative 3x squared. Well, that answer is just negative 3. So negative 3 times x squared is negative x squared. Negative 3 times negative 3x is a positive 9x, and negative 3 times 5 is a negative 15. And I'm going to write this over here because I've run out of space. The 3x and the 3x, or 3x squared and 3x squared will cancel. Negative 16 minus 9 is negative 16 plus 9, plus negative 9, which is 25x, and that's a negative. Negative 6 minus negative 15 is negative 6 plus a positive 15, and that gives me plus 9. Now, x squared will not go into negative 25x. So that's how I know I'm done. I cannot divide this term by that term. So this is my remainder. So when I write my answer out, I want q of x, well that's this term up here, this is q of x. So this equals 3x squared plus 4x minus 3 plus my remainder function, which is r of x, or negative 25x plus 9, and I divide that by my divisor, x squared minus 3x plus 5. So I have this entire fraction as my remainder part, which is this term here, and that is my answer. Now, synthetic division works a lot like synthetic substitution. It is, in fact, the process of dividing a polynomial by linear divisor of the form x minus k using synthetic substitution. So what you need to remember is that you can use polynomial long division or synthetic division, but you can only use synthetic division if you are dividing by a linear divisor. So if you're dividing by an x squared term, if you're dividing by an x cubed term, you cannot use synthetic division. You have to use polynomial long division. But if you have a linear divisor, x minus k, then you can solve using linear or using synthetic division. So what we'll do is we'll set k as the number on the outside of our grid. Be very careful with k because the term has to be x minus k, which means you need to flip the sign of this term. So if this were x minus 3, I would use a positive 3. If it were x plus 3, I would use a negative 3. So flip the sign. And remember, again, to use placeholders for any missing terms. So what I'll do is I will set up my grid for synthetic substitution, and I will put in the coefficients of my dividend term. So I have 2, a 1, a negative 8, remember your signs, and a positive 5. I don't have any missing terms here, so I don't need any placeholders. If I were missing that x squared term, though, I'd need a 0 here. If I were missing my constant term, I'd need a 0 here. So remember to use your placeholders. And then my number on the outside, if x minus k is is 3, then x minus a negative 3 would give me this. So I need a negative 3 out here. And then I just follow my substitution rules. Bring the 2 down. 2 times negative 3 is negative 6. Plus 1 is negative 5. Times negative 3 is a positive 15. Plus negative 8 gives me 7. And 7 times negative 3 is negative 21. Plus a positive 5 is negative 16. Now, what I need to remember is if I started with x cubed here, then this becomes my x squared term. This becomes my x term. This becomes my constant. And this is my remainder. So my answer here will be 2x squared minus 5x plus 7 plus, and the remainder will work the same way. It will be the remainder, negative 16, over the divisor, x plus 3. So I put x plus 3 here. And that is my answer. So I'm still finding a quotient polynomial and then a remainder number or polynomial and dividing that by the divisor polynomial, which is what I was dividing the whole thing by. So this here, this remainder, is going to be an important concept in the next theorem that we talk about. But this is synthetic division. It's a little bit shorter and a little bit easier than polynomial long division. But again, you can only use it when your divisor is linear. So when you have a degree 1 divisor. Now, these are the important theorems to remember here. The remainder theorem states that if a polynomial f of x is divided by x minus k, just like our synthetic division example, then the remainder is r equals f of k. So if we were to plug in -3 into our original function 2x cubed plus x squared minus 8x plus 5, we would get -16, which was our remainder. So when we do this synthetic division here, when we were evaluating a function for this number, we used synthetic division or synthetic substitution, and this was our number. So f of -3 is -16, which in this case is our remainder when we divide our whole function. Now, the factor theorem says a polynomial f of x has a factor x minus k if and only if f of k is 0. So this -3 is a factor of this polynomial if and only if, when we plug this in, our remainder is 0. So the number, so when you have x minus k, k is only a 0 if there is no remainder. We had a remainder on this question. It was -16. So if there's no remainder, if you get 0, if those cancel out to 0, then you have a factor, which is this, and that makes k your 0, or f of k equals 0. So this is again the relationship between a factor and a 0. A factor is a polynomial, a monomial, a binomial that makes this equation equal to 0. Now, factoring a polynomial using long division is another one of your objectives. So we've learned how to divide them. Now we're going to use that to solve them. We can factor a polynomial using division by dividing one factor to find the others. So if we have a factor, we can divide our polynomial by that factor to find the other ones. For example, if you have the equation 3x plus 6, and you know that one of the factors is 2, you can factor out a 2, so this equals 2 times x plus 3. Well, in order to find this equation, we would just divide that number by that number, and we get this original one, or this number by 2. Or this number by x plus 3, and we'd end up with 2. So the product of your factors equals your original, which means if you divide your original by a factor, you'll find the other factor, or factors, as the case may be. For example, we will divide this polynomial and factor it completely. So we know that x minus 2 is a factor. So k equals -2. Remember, this has to be x minus k, so this would be x minus a -2. So I'm going to set up my synthetic substitution chart. I have 3, -4, -28, and -16, and a factor of x plus 2, which means a 0 of -2. So now I will just follow my synthetic substitution rules. I bring my 3 down. 3 times -2 is -6, plus -4 is -10, times -2 is a positive 20, plus -28 is a -8, times -2 is a positive 16, plus a -16 gives me 0. So those cancel out. Because I have a 0 remainder, I know that that is a factor. And because it tells me a factor, I know I should get a 0 remainder. If I don't, and it tells me it's a factor, I've done something wrong. So now, my factor here is 3x squared, because this was an x cubed term, so I dropped that down to my x squared term, minus 10x minus 8, and I have no remainder, so I don't need to add anything else to the end of this. It would just be 0 over x plus 2, and that would just be 0. And there's no need to add a 0 on the end here. So I have these factors. X plus 2 times 3x squared minus 10x minus